LightHouse scores. They're the thing that your product manager pushes you to get sky high. They're the thing that the marketing and sales team claim matters so much to the web. They're the things that developers use to decide which frameworks do and don't make sense. And most importantly, they're the way that we shame every Angular app by pointing at these numbers and saying, look, see, Angular does suck. But does it? Do these numbers actually mean anything? And most importantly, can they be hacked? Can we just get LightHouse to lie? These are all great questions, and I'm really thankful to the channel sponsor Sentry for taking the time both to write this awesome article and sponsor this video so that we can talk about this. So huge shout out to Sentry, huge shout out to Salma. I'm so excited about this blog post. I've been waiting for it for a bit, and now we can go through it together. How to hack your Google LightHouse scores in 2024. Google LightHouse has been one of the most effective ways to gamify and promote web page performance amongst developers. Using LightHouse, we can assess web pages based on overall performance and accessibility, SEO, and what Google considers best practices, all with the click of a button. Do you know what we should do? We should make sure that this page has a good LightHouse score. Because we don't want to be reading something from a blog post that isn't accessible and isn't built properly, right? Like, come on. Too important. So now we're running LightHouse on the page. We'll see what the score is. In case somebody isn't familiar, LightHouse lets you rate all the things that Salma just said. And here we see decent scores, but the performance isn't great, and there are some accessibility misses too. Apparently there are some extensions that negatively affected the load time. They even give you the hint of using incognito mode to account for that. Yeah, there's background and foreground colors that don't have enough contrast, which is a very helpful hint to get. Links rely on color to be distinguishable. That's not always great. Usually you should have an underline or something too to indicate. But yeah, useful feedback. It's a good tool to quickly check something to see like, hey, are there things I can do to make my site better? And here, like there are in most sites, there's a couple of things you could potentially improve. Let's see what Salma has to say though. You might use these tests to evaluate out-of-the-box performance for front-end frameworks or to celebrate performance improvements gained by some diligent refactoring. And you know that you love sharing screenshots of your perfect LightHouse scores on social media. It's a well-deserved badge of honor worthy of a confetti celebration. Yep. One more thing you might not know is if you do manage to score all 100s, they throw confetti in. Nice little fun thing. But yeah. Anyways, the fact that LightHouse gets developers like us talking about performance is a win. I actually really agree with this. Even if LightHouse was theoretically entirely useless as a metric, the fact that it gets more devs to talk about performance in and of itself is great. Also that it gets us talking about accessibility and the way that other people might navigate our sites. Like LightHouse, whether or not it's great, is a massive net win and has encouraged us to make better websites that are more accessible and performant. So in that sense, obviously LightHouse is a win. But whilst I don't want to be a party pooper, the truth is that web performance is far more nuanced than this. In this article, we'll examine how Google LightHouse calculates its performance scores, and using this information, we'll attempt to hack those scores in our favor, all in the name of fun and science. Because in the end, LightHouse is simply a good but rough guide for debugging performance. Couldn't put it better myself. We'll have some fun with it and see to what extent we can trick LightHouse into handing out better scores than we may deserve. But first, let's talk about data. Field data is important. Yep, absolutely agree. Like if you're just testing this on your fancy $4,000 MacBook and seeing good performance numbers, that might not be the most realistic test. And even if you get a perfect LightHouse score using all of like the web.dev testing tools, like I know web.dev has a online tester. I don't feel like finding it, but a lot of these tools have ways to run LightHouse on their servers so that they can like monitor performance better. That's awesome, but it's not field data. It doesn't matter how fast these numbers say your site is if your users are having a slow experience. The only thing that matters is that your users are having a good time. And you don't get that data through LightHouse. Local performance testing is a great way to understand if your website's performance is trending in the right direction, but it won't paint a full picture of reality. Absolutely agree. The World Wide Web is the Wild West, and collectively, we've almost certainly lost track of the variety of device types, internet connection speeds, screen sizes, browsers, and browser versions that people are using to access the web, all of which can have an impact on page performance and user experience. Field data, and lots of it, collected by an application performance monitoring tool like Sentry from real-world people using your website on their devices will give you a far more accurate report of your website's performance than your lab data collected from a sample size of 1 using a high-spec, superpowered dev machine under a set of control conditions. Couldn't put it better myself. And again, if you do want to get this data, or more importantly, you want to know when things are failing for your users, you want to know when errors happen, you want to get feedback from those users, you want to be able to fix your app when it isn't performing right. That's what Sentry's great for. They have a wonderful performance monitoring dashboard. They have tons of good error management, all of those things. There's a reason I have them sponsoring the channel. They are the best way to make sure that your application is performing as expected for your users. I have talked with and even worked with other companies in the space, but from my experience, Sentry is by far the most production-ready way to keep your production-ready applications running how you expect them to. So if you're writing serious web applications and also serious mobile applications, Sentry is one of the best ways, if not the best way, certainly the best that I've experienced, to actually know when users are having a bad experience using your stuff. Huge shout out to Sentry. Again, thank you for sponsoring. I can't imagine plugging anything else in the space. They're the standard for a reason, and they are the thing that I reach for when I'm building applications. So this isn't just like I'm plugging the highest bidder. I could probably have gotten some more money from competition. I genuinely believe Sentry is the best solution. But yes, they sponsored this, so take my opinion with a grain of salt. Explore other people and other options. But if you're like me, you're going to go through the same journey and land on Sentry the same way that I did. Back to the article. Philip Walton reported in 2021 that almost half of all pages that scored 100 on LightHouse didn't meet the recommended Core Web Vitals thresholds based on the data from the HTTP archive. Very interesting that half of the sites that got a perfect LightHouse score don't actually meet Core Web Vital thresholds. Web performance is more than a single Core Web Vital metric or a LightHouse performance score. What we're talking about here goes way beyond the type of raw data that we're working with. Web performance is more than numbers. Speed is often the first thing that comes up when talking about web performance. Just how long does the page take to load? This isn't the worst thing to measure, but we must bear in mind that speed is probably influenced heavily by business KPIs and sales targets. Google put out a report in 2018 suggesting that the probability of bounces, which is somebody leaving the page, increases by 32% if the page load time reaches higher than 3 seconds, and it soars to 123% if the page load time reaches 10 seconds. Poor PHP devs getting owned here. So we must conclude that converting more sales requires reducing bounce rates. And to reduce bounce rates, we must make our pages load faster. What does load faster even mean? At some point, we're physically incapable of making a web page load any faster. Humans and the servers that connect them are spreading around the globe, and modern internet infrastructure can only deliver so many bytes at a time. The bottom line is that page load is not a single moment in time. In an article titled "What is Speed?", Google explains that a page load event is the following: an experience that no single metric can fully capture. There are multiple moments during the load experience that can affect whether a user perceives it as fast, and if you just focus solely on one, you might miss bad experiences that happen during the rest of the time. Absolutely agree. LightHouse is so focused on opening the page that it misses everything after that point. And if you can have a bad LightHouse score, but then an incredibly nice to experience site, that's great. Just a random example. I'm going to open up Chrome so that I don't have to use tabs and incog and all of that. Y'all might know about ping.gg. Ping is a site that I built to make it easier for content creators to do live video collaborations. We regularly get the feedback that this site feels super fast. I shouldn't say feels. People say the site is super fast because when they're navigating, they're clicking links, they're going places, everything happens instantly. But if I was to take the time to quickly run a LightHouse check, let's take a look at the LightHouse scores for the Ping homepage. They're bad. If you looked at this, you would look at Ping and assume, wow, that must be awful. Why would anyone want to use that? It's clearly so slow. The reality is that a lot of the things that are dinging our score here are things that don't actually affect the user experience. The first contentful paint's a little bit slow, but it's not terribly slow. We're right on that 3-second line. But we also get content relatively quick. A lot of the stuff that they're complaining about is because we have a video playing on the homepage. And this video player is a bunch of JavaScript because HLS.js kind of sucks, and there isn't a real alternative. Also, if we go to page speeds to test this, this will give us an even more neutral take because we are running it on a high-end machine. What if PageSpeed Insights runs it on something that's like intentionally quite a bit worse? Here we go. Running the same thing through PageSpeed Insights, we see a much worse 44 performance score. But our site's not meant to be a mobile experience at all. So I don't care about this number. As bad as it might seem, people think our website is incredible and super performant and great to use, because it is. And notice when I click desktop instead, it becomes a 95. We don't want our site to be used on mobile at all. We've actually barred it in multiple places on the site. When you're actually trying to go to a call, it says, oh, hey, you're on mobile. Don't be. We don't even let Firefox users use it because they have so many weird niche bugs with WebRTC and video. So yeah, You have to be considerate of your site and your goals and what you're trying to do. And to our users, we feel like the fastest website in the world. But to other users that might be on mobile sites trying to make a quick thing in their bank, the things that they're going to be looking for here are going to be entirely different. So that's an important piece to consider as we go through this, is that these metrics, even if they're bad, might not actually show you what the experience is like for those users. Our numbers look bad, but our users have a great time. Other sites might have a great number, but have a really bad experience for their users. So don't just rely on LightHouse. The key word here is experience. Real web performance is less about numbers and speed than it is about how we experience page load and page usability as users. And this segues nicely into a discussion on how Google LightHouse calculates performance scores. It's much less about pure speed than you might think. Oh boy, we're getting spicy. So how are these scores actually calculated? The Google LightHouse performance score is calculated using a weighted combination of scores based on core web vital metrics, like first contentful paint, largest contentful paint, cumulative layout shift, and other speed-related metrics, like the speed index and total blocking time. All of these are observable through the page loading timeline. This is how the metrics are weighted in the overall score. You have total blocking time, which is 30%, layout shift, which is 25, largest contentful paint, which is 25, first contentful paint, which is 10, and the speed index, which is an additional 10 points. Makes sense. This lets us see how Google prioritizes these different parts. Very interesting. A web page should respond to user input. The highest weighted metric is total blocking time, which is a metric that looks at the total time after the first contentful paint to help indicate where the main thread may be blocked long enough to prevent speedy responses to user inputs. So this is an important thing to measure. This is from when the user sees stuff to when the page is actually interactive, how much time is spent doing that. Because if the page loads and I start typing something on the page, if it can't respond yet because it hasn't finished doing all the rest of the work, that's a terrible user experience. And they weight that really heavily as a result. If it takes a long time to go from pages showing to you to pages interacting for you, that should hurt your score. And this is why things like Quick exist, which is a whole framework built around solving that problem, making it so when you see the content, it works as quickly as possible. So yeah, we're, as an industry, finding interesting solutions to these problems. The main thread is considered blocked anytime there's a JS task running on the main thread for longer than 50 milliseconds. Minimizing total blocking time ensures that a web page responds to physical user input, like key presses, mouse clicks, touching things, typing on your keyboard, all those types of things, need to not have your main thread blocked to work. A web page should load useful content with no unexpected visual shifts. Another important thing, we've all been to a website where we load the page, we go to click something, and it moves right before you click. That's content layout shift, or in this case, cumulative layout shift, which is how much are things moving after they're shown to you. And this is a really hard problem to solve, even in weird, unexpected places, like the React docs. See this fancy uwooified React logo? It's a slightly different size. Also, we have a value saved in local storage for which of these should be run. So if I go into my application code here and go to local storage, you'll see I have uwu set to true. I set that to false and I reload the page. You see the logo's in a different location. So in order for this logo switch to work and not cause the content to shift when I load the page, they actually had to block the main render, check local storage, and then swap that out before showing you the page in the first place. It was actually a somewhat complex pull request. And I talked a lot with core React team members, as well as with Guillermo Roche, the CEO of Vercel, about how hard it is to solve the simple problem of having a different logo depending on a specific flag without causing layout shifts. Interesting stuff. So that's why they're measuring it so heavily. The LCP and the layout shift are two very weighted metrics for a reason. LCP marks the point that in the page load time when the page's main content has likely loaded and is therefore useful now. So that's like if you go to Twitch, at first we have the skeleton and then things start to appear and load in. That initial skeleton is the first paint, and then once everything's done loading and you can interact, that's the largest contentful paint. That's when these tools assume the load is done. At the point where the main content is likely loaded, you also want to maintain visual stability to ensure that users can use the page and are also not affected by unexpected visual shifts. A good LCP score is anything less than 2.5 seconds, which is a lot higher than we might have thought, given that we're often trying to make our websites as fast as possible. Yeah, 2.5 seconds is kind of massive. So again, the number doesn't mean too much. Point 3, a web page should load something. The FCP metric marks the first point in this page load timeline where users can see something on the screen. and the speed index, SI, measures how quickly content is visually displayed during page load over time until the page is complete. Your page is scored based on the speed indices of real websites using performance data from HTTP Archive. A good FCP score is less than 1.8 seconds, and a good SI score is less than 3.4 seconds. Both of these thresholds are higher than you might expect when thinking about speed. They are. Those are pretty big numbers. Good information to have. This is a thing I die on the hill of a lot, where a lot of modern web tools, and especially a lot of old web tools, don't really have loading states for the users. So if you go to most PHP sites, the server is generating the HTML when you make the request. So you will often have to sit on that blank loading tab as the page generates the content. I'll actually quickly demo this because I think it's worth understanding. So I'm going to make a page in here that's slow/page.tsx. Export default async function home. Async function wait for. Good old Super Maven carrying my butt through this. I don't need all of that. Div, hi there. Close, save, nice. So now we have this page, slow/page.tsx, that will take a second to load. We're gonna bump that. We're gonna make it 10 seconds. Bun dev, go to an incog Chrome, go to localhost 3000. It loads pretty quick. Go to localhost 3000/slow. See that loading there? See that like we don't have any feedback. It's even worse if I go to a new tab and do it. We don't know if this is ever going to respond or not. The site might be down. The server might be down. When you're just sitting here waiting, it's hard to know, like, is the site even going to respond? I'm sure we've all sat here where we went to a page and it's like, oh, it's taking forever. Oh, it's because they're reminding you to subscribe. Turns out half of y'all haven't. Hit that subscribe button. Costs you nothing. Thank you. Anyways, this slowness sucks. And when you're navigating a site, it's even worse. If I was to go put a link on the home page, so we're going to delete all this content. I'm going to delete literally all of it. We'll have div ahref equals /slow other page. Cool. So now we have this other page link. We're going to click it. Did it work? What's going on? I'm going to click it again and see what's going on. Still waiting. This sucks. This experience is awful. And one of the biggest concerns I have with both the way technology used to work, where we had to wait for the server to send us HTML, but also new technologies, even really good things like Remix. If they encourage too much of block on the server until the user gets anything, that's bad. In my ideal world, we have some HTML that is stored on a CDN so we can get that to the user as fast as possible and then show a loading state after. What that would look like here is actually quite simple. We can put a loading.tsx here, export default function loading. Cool. And now when we load the same page, if I just close the tab and open it, we immediately get this loading response because it is immediately loading. It's able to store that in a cache somewhere, or even have that be JavaScript that's loaded on the user's device ahead of time so it can show you that while other things are happening. And the quicker you can get something to the user, the faster your site feels. It might not actually be faster, but when you click something and you immediately go somewhere, so if I click here, we immediately see the loading now. That feels better, even if theoretically it was slower. The fact that your action immediately results in a different UI, that's so important. So I like that they're weighing that so heavily in the scoring. I would actually weigh this heavier. I think FCP should be one of the top priority things because it's so important to how your site feels, and that bounce rate where if your site takes way too long to open, you actually lose metrics, which is another thing that's not mentioned here. If you are using a tool like Sentry and your site takes 10 seconds to load, you'll never actually know that because by that 10th second, a lot of the users are already gone. So the worst performance metrics that you could theoretically be seeing and getting, you don't see or get because the user churns before that can even happen. So it's important to know that your numbers, even if they look really bad, are not encompassing just how bad things are because you can't actually capture the worst case. Because the worst case, the user bailed. You never see it. So I think FCP should be weighted even stronger. That's just my personal hot take. That said, this is a fair point too. Usability is favored over raw speed. Google LightHouse's performance scoring is, without a doubt, less about speed and more about usability. Your SI and FCP could be super quick, but if your largest contentful paint takes too long and your CLS is caused by large images or external content taking some time to load and then shifting things visually, then your overall performance scores will be lower than if your page was a little slower to render the first contentful paint, but it didn't cause any cumulative layout shifts. This is a fair point too. If you're quickly rendering something wrong, and then you take a bit to render the right thing, but the right thing is too different and it causes things to move around the page a bunch, that sucks too. That sucks real hard. It's an important point, and I do like that they weight that so heavily, but I think FCP is important too. Ultimately, if the page is unresponsive due to JavaScript blocking the main thread for more than 50 milliseconds, your performance scores will suffer more than if the page was a little slow to paint that first contentful page. To understand more about how these weightings of each metric contribute to the final score, you can play around with the sliders on the LightHouse scoring calculator. Interesting, I didn't know they had that. Yeah, there's a calculator so you can see as these things move, how much does it matter. So if everything else was great, but the FCP took 6 seconds. So it took 6 seconds for the page to show anything, but everything else was fast. You're still getting a 90. That feels kind of shitty to me. I think that should be a lower score, but again, each their own, different opinions, different tools, different stuff. Measure these things in more ways. So here's a rudimentary table demonstrating the effects of individual metrics. Yep, cool. So you can see, oh look, they did the exact same thing where they set the FCP to max and everything else to 0, and they got a 90. They also tried setting SI to be the worst, everything else even, 90. And the other things have a much more significant impact. The overall Google Lighthouse performance score is calculated by converting each raw metric into a score from 0 to 100 according to where it falls on the Lighthouse scoring distribution, which is a log normal distribution derived from the performance metrics of real websites performance data from the HTTP archive. There are 2 main takeaways from this mathematically overloaded information. The first point is that your site's score is plotted against real web performance data, not in isolation. Important point. And also, given that the score uses a log normal distribution, the relationship between the individual metric value and the overall score is not linear, meaning that you can make substantial improvements to low performance scores quite easily because it becomes more difficult to improve an already high score. That is a fair point. Going from bad to good is a lot easier than going from good to great. You can read more about how the metrics are determined on developer Chrome.com. Good stuff. But here's where things get fun. Can we actually trick Google Lighthouse? Can we force it to give us a good score? I appreciate Google's focus on usability over pure speed in the web performance conversation. It urges devs to think less about aiming for raw numbers and more about the real experiences we build. That said, I've wondered whether today in 2024, it's possible to fool Google Lighthouse into believing that a bad page in terms of usability and usefulness is actually a great one. I put on my lab coat and science goggles to investigate. All the tests were conducted using Chrome Lighthouse plugin, using an incognito window in the Arc browser, using navigation and mobile settings, as well as them being in a lab, so it's not field data. That all said, I fully acknowledge that my controlled test environment contradicts my advice on the top of the post, but the experiment is an interesting ride nonetheless. What I hope that you'll take away from this is that the Lighthouse scores are only one piece, and a tiny one at that, a very large and complex web performance puzzle. And without field data, I'm not sure any of this matters anyways. Couldn't agree more. So let's take a look at how to hack these scores. TLDR, show the smallest amount of LCP qualifying content on load to boost the FCP and LCP scores until the Lighthouse tests have likely finished. I've seen this before. Pages that will delay a big paint until they think Lighthouse is done so they can get that score, they can get that ranking on Google, and then make the website usable. So they're literally making the website slower so they can skip that LCP check, get a good score, and then load it all in after. FCP marks the first point in the page load timeline where the user can see anything at all on the screen, while LCP marks the point in the page load time where the main page content, like the largest text or image elements, have likely loaded. A fast LCP helps reassure the user that the page is useful. Likely and useful are the important words to bear in mind here. So what counts as an LCP and element? Great question, and honestly, I don't have a concrete answer, so I'm curious to see how this goes. The types of elements on a web page that are considered by Lighthouse for LCP are things like image elements inside of an SVG element, video elements. This is the one that fucks me on ping, by the way, if you're curious, that we have an actual embedded video. We just deleted that, our page scores go up a ton. An element with a background image loaded using the URL function and not a CSS gradient. Important, because CSS gradients don't really count here. Block level elements containing text nodes or other inline level text elements. These following elements are excluded from LCP consideration due to the likelihood that they do not contain useful content. Things like zero opacity elements, things that cover the full viewport, like background elements, and placeholder images or other images with low entropy. So like low informational content like a solid colored image. However, the notion of an image or a text element being useful is completely subjective in this case and generally out of the realm of what machine code can reliably determine. Now I'm just scared that somebody's going to try and make an AI Lighthouse version that thinks it's better at determining these things. It's going to be a mess. We'll see how that goes. For example, I built a page containing nothing but an H1 element where, after 10 seconds, JS inserts more descriptive text into the DOM and then hides the H1 element. Is this live? This is. Cool. Let's go back to Chrome. I'm sure they're going to do this too, but why not do it ourselves? Let's generate a Lighthouse of this. Look at that. It thinks the page is perfect, even though, momentarily, the actual content will load. This page scored 100% on Lighthouse performance. The page took 10 seconds to load real content. The hello message was considered as the LCP element. Was it useful? No, because it didn't tell you anything was loading or how long you had to wait. It was one word. It could have been any word, but it passed the test. It also works with a single letter or punctuation mark. Yeah, that's terrifying. Lighthouse considers the heading element to be the LCP element in this experiment. At this point, the page load timeline has finished, but the page's main content has not loaded, even though Lighthouse thinks it is likely to have loaded within those 10 seconds. Lighthouse still awards us with a perfect score of 100, even if the heading is replaced by a single punctuation mark, such as a full stop, which is even less useful. This test suggests that if you need to load page content via client-side JS, we'll want to avoid displaying a skeleton loading screen since that requires loading more elements on the page. And since we know the process will take some time, and that we can offload the network requests from the main thread to a web worker so that it won't affect the TBT, we can use some arbitrary splash screen that contains a minimum viable LCP element for better FCP scoring. This way, we're giving Lighthouse the impression that the page is useful to users quicker than it actually is. Yep. All we need to do is include a valid LCP element that contains something that counts as the FCP. While I would never recommend loading your main page content via client-side JS in 2024, serve static HTML from a CDN instead, or build as much of the page as you can on the server. Yep, totally agree. I would definitely not recommend this hack for a good user experience, regardless of what the Lighthouse performance score tells you. This approach also won't earn you any favors with search engines indexing your site, as the robots are unable to discover the main content while it's absent from the DOM. If you have all of your content come in via JavaScript way later, yeah, not good. And it really does showcase that, like, if you just blindly follow these scores, like, I could go do all of these things to the ping site to maximize our Lighthouse scores, but we'd be making the site worse. Not saying all single page apps are bad, not saying all JavaScript on the client is bad. I'm saying that intentionally throwing so much on the JavaScript client side just to get around these scores is hilarious and not good. Really good point from Gabriel from chat. What I truly hate about Lighthouse is the fact that the scores do count towards SEO rankings. Now product managers, program managers, whatever you want PMs to stand for in any given context, have real leverage to make it a requirement. Yep. Anyways. I also tried this experiment with a variety of random images representing the LCP to make the page even less useful. But given that I used small file sizes, made smaller and converted into next-gen image formats using a third-party image API to help with page load speeds, it seemed that Lighthouse interpreted the elements as placeholder images or images with low entropy. As a result, those images were disqualified as LCP elements, which is a good thing, and it makes the LCP slightly less hackable. This hack, however, probably won't hold up in many other use cases. Discord, for example, uses the splash screen approach, where you hard refresh the app in the browser, and it receives a sad 29 performance score. Compared to my DOM-injected demo, the LCP element was calculated as some content behind the splash screen, rather than the elements contained within the splash screen content itself. Given that there was one or more large images in the focus text channel I tested on. One could argue that Lighthouse scores are less important for apps that are behind authentication anyways, because they don't need to be indexed by search engines. This is also a really good point. The Lighthouse score on a page that requires auth doesn't matter at all, not because like it's useful data, but the fact that Lighthouse itself and the scores you get from Lighthouse itself affects SEO doesn't matter if the page is stuck behind auth anyways. And this is an example of like running it on a Discord channel. And you can see these numbers look awful, but in the context of it being the Discord site running in mobile, which they would never recommend, they tell you to go use the app, means that this number is meaningless, but also since these things are being indexed, they don't have to care. There are likely many other situations where apps serve user-generated content and you might be unable to control the LCP element entirely, particularly regarding images. Images and video are the bane of Lighthouse existence. It's so bad. For example, if you can control the sizes of all images on your pages, you might be able to take advantage of an interesting hack or optimization, in very large quotes, to arbitrarily game the system, as was the case of RentPath. In 2021, developers at RentPath managed to improve their LightHouse score performance by 17 points when increasing the size of image thumbnails on a web page. They convinced LightHouse to calculate the LCP element as one of the larger thumbnails instead of a Google Map tile on the page, which takes considerably longer to load via JS. This is actually a great example. They have a blog post on it too. So they increased the size of the thumbnails, and by doing that, this became part of the LCP, which is how they would measure it, and they were able to skip the map part as a result. Make the thumbnail image larger on the search results page so we can control the largest element on the page and ensure that it loads quickly, unlike the Google Map. That's great. Yeah, the score is based on how big it is, literally, how much of the page is it taking up. So this being faster than this didn't matter until it was also literally bigger and took up more of the page. And then the increase of making this larger and literally making the page load slower actually helped their LCP. Really interesting stuff. The bottom line is that you can gain higher LightHouse performance scores if you're aware of your LCP element and you're in control of it, whether that's through a hack like RentPath's or mine or a real deal improvement. That being said, whilst I've described the splash screen approach as a hack in this post, that doesn't mean that this type of experience couldn't offer a purposefully and joyful experience. Performance and user experience are about understanding what's happening during page load, and it's also about intent. So how can we hack the CLS score now? TLDR, we can defer loading content that will cause layout shifts until the LightHouse test has likely finished because it thinks it has enough data. CSS animations using transform won't cause cumulative layout shift, except if used in conjunction with adding new elements to the DOM. CLS is measured on a decimal scale. A good score is less than 0.1, and a poor score is greater than 0.25. LightHouse calculates the CLS from the largest burst of unexpected layout shifts that occur during a user's time on the page based on a combination of the viewport size and the movement of unstable elements in the viewport between two rendered frames. Smaller one-off instances of layout shift may be inconsequential, but a bunch of layout shifts happening one after the other will negatively impact your score. Absolutely makes sense. So if you have a bunch of things moving around as elements load in, that's a terrible experience, and you get killed in the scoring as a result. So how do we hack it? If you know your page contains annoying layout shifts on load, you can defer them until after the page load event has been completed, thus fooling LightHouse into thinking that there is no CLS. The demo page that they created here, for example, earns a CLS score of 0.143, even though JS immediately starts adding new text elements to the page, shifting the original content up. By pausing the JS that adds new nodes to the DOM by an arbitrary 5 seconds with a set timeout, LightHouse doesn't capture the CLS that takes place. So if I go back to Chrome and we load this page, that's awful. Everything moving around constantly. It's a great example of this sucking. So let's run the LightHouse here. It thinks it's good. The layout shift is nowhere near as bad as you would expect, considering that the layout shifted that much. Apparently, this one's even worse. Yeah, that's way worse, because it's just delayed. So the only change between these two pages is this one takes longer to start, but it's going to get a perfect score, unlike the other one did. Yeah. Look at that perfect score. Look at that confetti on a page that objectively sucks by design. We had the confetti going off for multiple seconds before the page layout even started to shift. That's insane. Yeah, as they said, even though this is less useful and usable than the last page, given the added elements pop it in seemingly at random without any user interaction. Yep. While it's possible to defer layout shift events for a page load test, this hack definitely won't work for field data and user experience over time, which is a more important focal point as we discussed before. If we perform a time span test in LightHouse on the page with deferred layout shifts, LightHouse will correctly report a non-green CLS of around 0.16. Thankful that there are tests that actually confirm that, but still not great. If you do want to intentionally create a chaotic experience similar to the demo, you can use CSS animations and transforms to more purposefully pop the content into view on the page. Also a very important point. If these movements and changes are happening because of CSS, not because of JS updating the DOM, LightHouse doesn't give a fuck. LightHouse effectively ignores CSS. In Google's Guide to Cumulative Layout Shift, they state that content that moves gradually and naturally from one position to another can often help the user better understand what's going on and guide them between state changes. Again, highlighting the importance of user experience in context. Yes. On this next demo page, I'm using a CSS transform to scale the elements from 0 to 1 and move them around the page. The transforms failed to trigger CLS because the text nodes are already in the DOM when the page loads. That said, I did observe in my testing that if the text nodes are added to the DOM programmatically after the page loads via JS, and then they're animated, LightHouse will indeed detect the CLS and score things accordingly. Interesting. I will say that this is better, like as a user even, in the sense that none of the elements move once they're placed. So even if it's silly that CSS doesn't count towards this, this is actually a better site because nothing moves once it's placed, where with like the non-hacked CLS, things move around a whole bunch when they appear. That's a worse experience than this is because once it's placed, it stays there. So yeah, controversial, but I do think that's objectively better. Apparently, you can't hack a speed index score, though. The speed index score is based on the visual progress of the page as it loads. The quicker your content loads nearer the beginning of the page load timeline, the better. It's possible to do some hack to trick the speed index into thinking a page load timeline is slower than it is. Conversely, there's no real way to fake loading content faster than it does. The only way to make your speed index score better is to optimize your web page for loading as much of the page as possible as soon as possible. While not entirely realistic in the web landscape of 2024, mainly because it would put designers out of a job, good pun there, you could go all in to lower your speed index as much as possible by doing some of the following. You can deliver static HTML web pages only straight from the CDN. I mentioned this earlier, actually. If you have HTML on a CDN, you get that content way faster, even if you have to do more things after. The quicker you can get that initial HTML to the user, the better experience, period. And if you can skip SSR for your time to first byte, if you can get the user something before your servers even spun up, much less generated a response, that's a great thing. And you should find ways to do that. You can also avoid images on the page. Again, you just need to load less stuff. You could also make the images smaller. Something I should have mentioned earlier is the Next image plugin. Vercel and Next now includes this image component, which might not seem particularly great. Like, why does my framework have an image component? The reason is that they will actually optimize the images based on the specific browser loading the content. If you're loading the Next.js web page with an image on it on an old Internet Explorer browser, the best image type is probably JPEG. But if you're loading it on something more modern, it's probably WebP or AV1F. And the fact that the image component allows them to hit an endpoint in Next to generate the right image means that the user will almost always have a better experience just because the image that's actually mounted here isn't going to be the original PNG. It's going to be some optimized version of that picture. Even if I go to like my own image management tool, if I look at one of these thumbnail faces and we inspect it, the actual source tag for that is some crazy shit because this is my service optimizing this image from upload thing. And you'll see that the image type, it might say PNG here, but what loaded here, I promise you, that is not a PNG. Save image as. It doesn't even have an image type there. Fun. But I promise you this is not a PNG. This is some crazy optimized shit based on the size it renders on the page, based on the types of formats that the browser can handle, all of those things. Apparently network tab file type will let me actually see. Yeah, cool. These are all coming in as WebP because again, the PNGs I uploaded, or I guess JPEGs are what I uploaded, are not optimal for the user. So Next specifically will replace these with WebPs that it generates so the page can load faster. And that is a great thing. So you can actually make it faster by doing things like that, but that's not a hack. That's an actual objective win for your users. You can also minimize or eliminate CSS. Always a good thing. You should check out Tailwind. Great way to do that. But also, you can prevent JavaScript or any external dependencies from loading. Yeah, there's also ways that you can delay this too. If you were to delay the JS tags from being mounted until that 10-second window has passed, you can hack that for sure. But we also can't really hack a TBT score. TBT measures the total time after the first contentful paint, where the main thread was blocked by JavaScript tasks for long enough to prevent responses to user inputs. A good TBT score is anything lower than 200 milliseconds. JS-heavy web apps, like single-page applications, that perform complex state calculations and DOM manipulation on the client on page load, rather than on the server before sending the HTML, are prone to suffering poor TBT scores. I can show this pretty easily. It's going to do the mobile version, which is going to look way less bad. It'll still be bad, though. See that performance score? That's because Twitch doesn't exist until the JavaScript's running on the client. It has to run everything. It has to generate basically the whole page on the client. So your scores are always going to be terrible because it has to do that. If I switch this to be a desktop test, it's going to be even worse. The score might look better because they give it more performance. They give it more CPU. But the fact that this much stuff happens is the issue. That it takes that long and that much stuff happening before you can actually see the results. Yeah, still a terrible score. So important to consider. Single page apps will always have problems here. In this case, you can probably hack the TBT score by deferring all JavaScript until after the LightHouse test is finished. Fair point. I mentioned that before, where if we have a single inline script that after 10 seconds loads the real JavaScript, you can get around it like that. But then you're waiting 10 seconds before the page can actually start to generate. That said, you need to provide some kind of placeholder content or loading screen to satisfy the FCP and LCP, as well as to inform users that something will happen at some point. Plus, you'd have to go to extra lengths to hack around the front-end framework that you're using. You don't want to load a placeholder page that, at some point in the page load timeline, loads a separate React app after an arbitrary amount of time. Yep. What's interesting is that while we're still doing all sorts of fancy things with JavaScript in the client, advances in the modern web ecosystem are helping us all reduce the probability of a less than stellar TBT score. Many front-end frameworks, in partnership with modern hosting providers, are capable of rendering pages and processing complex logic on demand without any client-side JavaScript at all. While eliminating JS on the client is not the goal, we certainly have a lot of options to use a lot less of it, thus minimizing the risk of doing too much computation on the main thread on page load. I couldn't agree more. If you want to learn a bit more about this, I have a video called Airplane Proof website, I think. Yeah, my website is Airplane Proof. Funny enough, got that good old LightHouse score in there too. I showcase a bunch of cool things that the new Next App Router stuff enables that I think is dope. Check that out if you haven't. Anyways, the bottom line, LightHouse is still just a rough guide. Google LightHouse can't detect everything that's wrong with a particular site. Whilst LightHouse performance scores prioritize page usability in terms of responding to user input, it still can't detect every terrible usability or accessibility issue in 2024. In 2019, Manuel published an experiment where he intentionally created a terrible page that LightHouse thought was pretty good. I hypothesized that 5 years later, LightHouse might do better, but it doesn't. On the final, that's actually hilarious that this old page still gets a perfect score. On this final demo page I put together, input events are disabled by CSS and JS, making the page technically unresponsive to user input. After 5 seconds, JavaScript flips a switch that allows you to click the button. The page still scores 100 for both performance and accessibility. That's actually a great little test. To literally make the page not work at all and still get a perfect score is hilarious. You really can't rely on LightHouse as a substitute for usability testing and common sense. I agree full-heartedly. Oh boy, more silly hacks. As with everything in life, there's always a way to game the system. Here are some more tried and tested guaranteed hacks to make your LightHouse performance scores artificially knock everyone else's out of the park. Only use LightHouse tests using the fastest and highest spec hardware. Make sure your internet connection is the fastest it can be. Relocate if you need to. Never use field data, only lab data. Collected using the aforementioned fastest and highest spec hardware and super speed internet connections. And rerun the tests in the lab using different conditions and all the special code hacks I described in this post until you get the results that you want to impress your friends, colleagues, and random people on the internet. And if you can figure out the IP address that something like the page speed test is using, maybe restrict them into a different version of the page that loads things instantly. This is a fun note at the end here. The best way to learn about performance and how to optimize your websites is to do the complete opposite of everything we've covered in this article all of the time. And finally, to seriously level up your performance skills, use an application monitoring tool like Sentry. Totally agree. Think of LightHouse as the canary and Sentry as the real deal production data capturing lean, mean web vitals machine. And finally, here's a link to the full demo site for educational purposes. That was phenomenal. Once again, huge shout out to Sentry for sponsoring me and making this possible. Huge shout out to Salma for writing this awesome article. And huge shout out to y'all for hanging out. Let me know what you think, what worked, what didn't, and why you think LightHouse scores do or don't matter. Until next time, peace nerds.